Okay. Bismillah ar-Rahman ar-Rahim. This is Shahid Muhammad Abdulaziz. I'm from the Electrical Engineering Department, Electrical and Computer Engineering actually department here at the College of Engineering, King Abdulaziz University. I'm here today to introduce to you an enhanced computer-aided diagnosis system for automated classification of cardiac ECG signals. So, first of all, I will talk about my introduction and background, simple background information as well as introduction, then followed by literature review, research methodology, results and discussion, and finally conclusion and possible future work points. In our body systems, we have a normal heart beating process where the blood is coming to all of our body parts from the heart. So this is our normal heart beating process. We know that our heart has 4 chambers, has 2 main nodes to control our electrical activity of the heart. So those 4 chambers, which are atrium, 2 atrium and 2 ventricles, will just control the whole process of normal heart beating, and this will just remove our deoxygenated blood from our body parts and giving the oxygenated blood to the lungs and to the body parts again. The main problem is if this is damaged or is not going in a proper manner, so the whole parts of the body will damage and make the person die. So we have to know the normal heart beating process, if it's going on in right way or not. So the way is by having our ECG or electrocardiograph or electrocardiogram. So this is the signal of our normal heart beating process. This is the normal case, where, as I said, we have atrium and we have ventricles 2 by 2. So this one P wave will reflect our atrium depolarization, yes, and followed by QRS complex, which is a ventricular depolarization. So both have depolarization, one for atrium and one for ventricle, and finally T wave, which is for ventricular repolarization process. So by this process, we are guaranteed that the heart is beating in the normal way. However, how can we detect that if the heart beating process has some problems? Any problems, if that heart beating process might cause arrhythmia. So this kind of arrhythmia or those arrhythmias have to be detected and have to be dealt with in right manner and correct manner as well. So, for example, if electrical activity of the heart is going to be too fast or too slow, or generally irregular recorded heartbeat, which is I just mentioned earlier. So this is called a type of arrhythmia and has to be dealt with. So arrhythmias, some of them or most of them are life-threatening types and may causing death, and fast and accurate action is needed to be there. Okay, we will focus here. Of course, arrhythmias are many types, as I mentioned. So I am focusing here on maybe 4 types of arrhythmias, which are ventricular couplet, ventricular tachycardia, ventricular bigamy, and ventricular fibrillation. We will mention them later as VC, VT, VB, and VF. The first 2 letters of them. Okay, as a background or as an introduction, which might push me to do this work. Always they are seeing that numbers are not lying. The number is a very important indicator for the heart beating process, for the problem to be dealt with. So let's start for this general information given by disease control responsibility or given in US, for example. This is disease control disease center for the cardiovascular problems. Say that those kind of diseases or heart diseases are leading causes of death in US as well as in many countries. So, for example, 34 seconds, if we take less than a minute, or around half a minute, in US there is a person dies because of cardiovascular disease. Also, around 700 people are died because of heart disease in 2020, COVID-19 year, corresponding to 1 in every 5 deaths. So it's a huge number to be dealt with. It's also an economical issue. For example, according to CDC also, heart diseases cost US about 230 billion each year from 2000 to 2017 to 2018. Every 40 seconds, someone will have a heart attack there. This is a huge number. Every 40 seconds, it's around 20%. The problem is, most of them are silent. They are just detecting the problem after the damage is done. We have to have a way to early detection of the problem. So most of them, 1 out of 5, 20% of our heart attacks are silent. So this is a big problem. For example, this is the deaths in 1,000 US because of cardiovascular disease problem. So see from 2020 until 2000, the number is going down a little bit, but before that, the number is increasing in normal and in just a clear way. So, according to American Heart Associations in 2019, because of strokes, as well as heart diseases, someone died every 3 minutes, 30 seconds in US. So causes must be taken in mind, but we have to have a system. So this has pushed me to do this kind of work, or to focus in this area to be work on. The case is the same for Europe, especially. So in Europe also, the heart diseases are main cause of death. So as I mentioned, 4 types to be taken in mind: VC, VB, VT, and VF. Let's take those are life-threatening types of ventricular arrhythmias. So ventricular couplet, any couple of premature beats coming from ventriculars and happening in such a sequence with no intervention of normal beats. So 2 premature beats following each other. This is a ventricular couplet. Ventricular tachycardia, it's a very fast rate. We are talking about supposed to be 60 to 70 beats in normal way, but this reaching to like 100 beats. So great importance of early detection here in this case. Ventricular bigamy, actually this has a problem, which is a premature ventricular complexes. When those complexes are happening, this is called ventricular bigamy. So it has to be dealt with again. Anteroventricular fibrillation, this is the most serious one of all. All of them are life-threatening, but this is the most serious one. This could lead to death in minutes. And represented by absence of effective electrical activity of the heart, causing ventricular to vibrate like this one, like this. This is our ventricular fibrillation. This is our typical heartbeat. So this fibrillation and in ventriculars causing the ventricular fibrillation. This is the case of tachycardia. As I mentioned, very fast moving, very fast waveform. So too fast, too slow waveform are problems and need to be dealt with. Many studies have been. Now we are moving to literature review section. Actually, many studies have been read. I will focus just on 5 types of studies. For example, this study has used a Butterworth low band pass filter with total of around 40,000 features to be extracted. So this is a huge number of features actually. From given ECGs, feature extraction was based on the waveform like peaks and valleys of the waveform. The system has been resulted with F1 score, which is a kind of measuring the accuracy. It's a measure of accuracy of the given signal of around 98 and 97 on patients with additional cardiac condition and the system without additional cardiac condition. Actually, they have used two types of classifier, which are extreme gradient boosting tree classifier and gradient boosting tree classifier. So it's clear from this study that they have used the tree classifiers types. Then another study has used a Butterworth high pass filter and band pass filter with total of 110 features using of gradient boosting trees classifiers. The third one has used transform domain feature extraction way by using of fast Fourier transform with a resampling technique, add convolutional neural network, and they have used normalization as well. The fourth one is very important since this one has used almost the same way of, not the same, near way of my feature extraction process, but not the classifier. They have used XG boosting classifiers with using of isolation forest algorithm. I'm not talking about the algorithm. Resulted with high accuracy, actually, with 97 percentage. And the final work or the final type of studies has not proposed the CAD system or computer-aided diagnosis system. Rather, this is a review study. This was very useful for me just to focus how the thing is going to be done. So this was very helpful tool for me. They have mentioned how to extract features, how past studies extracted features like atrial features, ventricular features, and signal features. Also, they have mentioned that the families of classifiers like SVMs, support vector machine, neural networks, k-nearest neighbor regression analysis. So this was very helpful to know how the process is going on, and this is the goal of literature review. How do I establish my work? I didn't like, firstly, or all of other works didn't like pre-processing step. This is like normalization. This is like resampling. So they are using how to prepare a signal to be ready for feature extraction process. Feature extraction, three main points of feature extraction: statistical features like mean, standard deviation, etc. And then the domain transform features like Fourier transform way and wavelet analysis. And finally, morphological features, which is depend on the waveform, how it's going to be right or wrong. Then classification techniques, like as I mentioned, the family of the classifiers like SVM classifiers, logistic regression, and other possible classifiers. In most done works, they have used k-fold cross-validation, which is a technique to randomly divide our data for testing and learning process. Most of them has used 5-fold cross-validation technique. However, only one work have used 2-fold cross-validation technique, and another one have used 10-fold cross-validation technique. Finally, evaluation techniques. So how to evaluate your work, is it good or not? Most of proposed CAD system have used MATLAB or Python. Anyway, in mentioned works, no done works mentioned that they have used classification learning app or all of classifiers. Thus, in this proposed system or thesis, we will use this classification learner app along with trying of all possible classifiers will be done to reach best possible results. So this is our main methodology. Firstly, we have the data. Then pre-processing step, mainly will be resampling of the data. Then feature extraction process. And one very important point here, this is an iterative process. So to reach best feature extraction, you have to do it in iterative way. One way, direct features will not give you best result, and we will see this one later. Then classification, which is by classification learner app, and then an evaluation process by doing of performance assessment. Firstly, the idea was dividing given data as 66% for learning processes and 33% of given data for testing processes. However, the idea has been changed by applying a 5-fold cross-validation technique, which will divide the data 80% randomly given to learning on trade, training processes, while the other 20% of the dataset has been given for testing purposes, all by AI, artificial intelligence, established in classification learning app. This process has been repeated 5 times. This is the idea behind using of 5-fold cross-validation. It's better to divide the data randomly than assigning it by yourself. We have used the resampling actually here for 360 samples per second for the 3 classes of our 4 classes of our 5 classes, while the VF or ventricular fibrillation has been resampled at 250 samples per second. Again, iterative feature extraction process to reach best possible results. The system has been tried 2 ways. Firstly, we have tried to classify given signal only to normal, abnormal to make things easy. Then we have used it for 5 classes, mentioned 5 classes. Normal plus our 4 ventricular life-threatening arrhythmias. Again, we have used classification learning app for the performance assessment. We have used accuracy, the main measurement to measure the whole system, sensitivity, specificity, BPV or positive predictive value, negative predictive value error rates, as well as having the area under the curve results from ROC curve produced by the system, the classification learning app, and we will see this later. All of our steps have been developed by MATLAB. Firstly, we have used a well-known source for the dataset, MIT BIH for an arrhythmia database. We have taken 3 seconds long ECGs, totally of 480 ECGs. We have 5 classes. Each system has 96 signals, totally of 480 ECG signals. So 5 classes. The first class, which is normal one, is 96 signals. And the other one, every class has 96 signals, totally of 480 signals. After that, we have applied 5 cross-validation technique to divide our data. In case proposed system is used for only normal, abnormal classification, we have used all of other classes as abnormal. For example, this is a samples of our signals gotten from the data set. So, first one and last one are normal ECGs, and this is a type of ventricular tachycardia. This is supposed to be, for example, a class 2, class 3, 4, 5. Those all are class 1. In case the system has been used for 5 classes classification or multi-class classification. However, if the system has been used only for normal and abnormal classification, those 2 will be normal, and all of others are abnormal signals. Representing out our 480 ECG signals. For feature extraction process, firstly, we have used our basic first order statistical features like mean, standard deviation, mean of derivative, and standard of derivative. The higher accuracy resulted with this system is 77 by weighted KNN classifier. However, we have used another totally transformed domain features alone. So best accuracy resulted with 45 with cosine KNN classifier. Here we have used FFT, not wavelet transform. Then we have used a higher first order statistical features like standard deviation to the higher power 2, mood, variance, quantile, percentile, the same way, and other morphological features. Actually, those features have been taken from an ECG extractor toolbox built in MATLAB. Not built in MATLAB, I have downloaded it, and then I have used it with my data set, tried to change something in it to be fit with my data set. So with them alone, I got 71 with final tree classifier. Then I have to combine each other. So I have combination between first and second group, 61 or 62 almost as best accuracy resulted with final tree classifier. Then with wide neural network classifiers, combination of all given features. this has been used for a multi-class classification only, not two classes, because two classes we usually have best results. For classification, as I said, totally of 480 into normal, abnormal classification, or 1 out of 5 classes. Firstly, we have tried to best useful features in MATLAB. So in case of normal, abnormal classification, we got around 84 as useful features out of 94 features. For normal abnormal classification, for 5 class classification, we got around 79, around 80 features are useful with a t-test value used in MATLAB. However, with application of a classification learner app, all features have been used, and we have applied the PCA, or principal component analysis, which will make the features less, and we will see the effect of that later on results section, inshallah. So all 32 classifiers have been used, and those are the name of all classifiers have been used from the families of classifiers, as I mentioned, which are here as their MATLAB helping tool. We have decision trees, discriminant analysis and classification, naive bias, classifications, SVM, classification, neural networks, k-nearest neighbor. All of them are families of our classifiers. To assess our system, we have used those. Actually, the accuracy is the main measurement here, but the accuracy is resulted from the system. So we have to calculate sensitivity, specifically, positive predicted value, negative predicted value, and error rate. TB stands for true positive, TN stands for true negative, and false positive and false negative for FB and FN. In case of normal abnormal classification, this is our confusion matrix. So here will be true positive, for example. Here will be false positive, false negative, and true negative. Application of those mentioned equations will be simply gotten our performance assessments. In case of our system has been used for multi-class classification, we have to use for each class. For each class, we have to calculate our performance assessments. For example, this is for class 1 only. So this is our true positive, and this is our true negatives, and this false negative, false positive. For class 3, for example, this is our true positive, and false positive, false positive, false negative, and true negatives are the remainings. This is sample for every classifier, 32 classifier for normal, abnormal classification and 5 class classification. We got 4 figures from the system. The most important 2 are those, which is the confusion matrix. As I said, for just plug in the confusion matrix from in previous mentioned equations, and the ROC cat, which is another important assessment for the performance assessment of our system. This is the case of 5 classes or multi-class classification for area under the curve are for the confusion matrix. Again, all of them has been used or has been gotten from the classification learner app. Actually, Excel was very useful here. Just the way it's going like this. We have applied the PCA with every time. So, applying the PCA, which is principal component analysis, by AI, by artificial intelligence, will make the features less, or will try to take the only useful features. Okay, so for firstly, we have started with normal abnormal classification with and without application of PCA. So we will have two results types. Then we have with and without application of PCA for multi-class classification. We have in appendixes, we have all of our results in details and in figures. I will go with the best results I got in. Firstly, we have normal abnormal without application of PCA. So we have wide neural network with best accuracy reached by 98.3. This is the best accuracy for only normal abnormal classification. All of other performance assessment has been calculated, sensitivity, specificity, as I said, by helping of equation existed in Microsoft Excel. However, application of PCA we got the best accuracy as 87.7, so the accuracy has been lower. To reach best possible PCA, firstly, we have applied firstly the variance percentage as 95, sorry, then followed by 97 percentage, 99. This is the best possible results with application of PCA. The system has got 4 out of 94 features or group of features. So the best possible accuracy was 87.7. It's expected that with a multi-class our accuracy will go down. This is a normal case. So for application, without application of PCA for a multi-class classification, we got a wide neural network, 89 as a percentage of accuracy, and we have calculated other performance assessment for each class. First class is normal, VC is the second class, VT is the third one, PB fourth one, and VF is the class 5. Application of PCA again. See, the accuracy is going down, very down, so around 69, even we cannot see 70, 69.2 percentage with a cubic SVM classifier. This is our best results for application of PCA in both cases, in 2 classes and in 5 classes. Generally, it's expected to have lower accuracy result with more classes. So if we have 90 classes, we will have lower accuracy. Application of PCA has affected the system by making the results accuracies lower, not higher. Steps in general point of view have the same as previous work. However, the difference by application of the idea of classification learning app as well as having an iterative technique for the feature extraction. The idea of this system with a 2 classification has been applied before this with this system. Mentioned in literature review, he has applied classification system firstly to normal abnormal classification, then a multi-class, but he has only 3 classes. Resampling technique is a well-known technique applied by all those works mentioned in literature review. Also, the Iranian database we have used in our ECG signal is a well-known source. It has been taken used by 3 systems. Here, those systems mentioned also in our literature review section. For feature extraction, statistical features, those are very important. The importance of them has been emphasized in those two works. And those works, this work and this one, those 3, 1, 2, 3, have used transform domain features as mine. So they have used FFT as well as wavelet transform. And the third group, which depends mainly on morphological features, has been used. The idea of morphological features has been used in those 4 systems mentioned in the literature review. Because of time, I will not go in details with those systems. The idea of multi-class classification has been applied with all this work: 26 classes, 4 classes, 27 classes, 7 and 4 classes, 2 cases, 17 cardiac rating classes, 26 classes. So our classes are acceptable as 5 since it has been applied before this with a little bit higher or less than this number. So in comparison with other done works, proposed system is the only one using those all families of classifiers. Most of other works have calculated performance assessments, as I did. But the performance assessments differs. Some of them has used only accuracy, F1 score. So model 2.5, which is quadratic discriminant, has not worked without application of PCA, so we have to apply a PCA with that. Table 4.19 in done work has a comparison between all 30 works done in the literature review as well as mine, in terms of resampling techniques or pre-processing techniques, feature extracted, and used classifier as well as performance assessments, if mentioned actually. Also, results of a proposed system could be said that it could be generalized in real world. So, in conclusion, we have done firstly pre-processing step, then we have an iterative feature extraction using of all classifier and then performance assessments. New things and principles have been done or learned in this work, how to use the app, how to use, or a new principle for me actually for a k-fold cross-validation, which is a new principle for me. And iterative techniques, how to improve things step by step, not only get plug in and get the result. No, you have to apply or build it step by step. Also searching through the internet to similar of my work or going in reviews and going work by work to reach to your goal. Those are many of things learned in this work, exactly. Better performance could be reached? Sure, 100%. Every work has some problems in it, and better performance could be reached, actually. Best result could be interpreted in different ways. As I said, I have many performance systems. For example, if one just focusing on negative predictive value. So I was focusing on the accuracy of the system. For example, he wants some system to focus on negatives. So he may got another result, another best classifier from my system. I have calculated negative predictive value. He has to focus on this. I have focused on the accuracy as main measurement. Manual detection in the area of many errors. We have to have a system for an early accurate detection if possible, because of reasons as I mentioned and number as I mentioned. So for future, having better accuracy results could be by adding more features. So trying to add more features as well as larger data sets. Increasing number of data sets, as I said, making process faster. For example, someone may try Python, for example, or faster and easier if possible. Having same techniques for other cardiac of arrhythmia, other types of arrhythmias or cardiac abnormalities, or other things like cancer, for example, is recommended also. Building of technology and artificial intelligence with a lesson, no end in this building of technology. So many tries will give you better results than my system. References, codes are available upon requests. This is all for now for my system. Many thanks for your listening, and I'm happy to hear from your recommendations, your questions. Thank you.
So we should probably convention start with the external examiner.
Yes. No. كمان يا شادي معلش انت قاعد تعمل تصوير دحين ولا؟
Okay. But this is for mine.